Think about your favorite movie, a song that energizes you, or a video that instantly transports you back in time. Android has become the go-to surface for billions of users to create and experience these deeply personal and powerful moments. We empower device makers and developers with the underlying tools to turn snapshots into lasting memories, playlists into personal anthems, and videos into impactful narratives. Good afternoon, everyone. Welcome to Building Modern Android Media and Camera Experiences. I'm Karthic, Veera, Product Manager for Android Media and Camera. Also joining me today are Jolanda, Caren, and Dan from our Developer Relations team. We are incredibly excited to be here at Google I/O, surrounded by people who are passionate about building great experiences on Android. So let's dive deep into powerful features and APIs that are shaping the future of Android media and camera.
Let's start where the power of these media experiences shines brightest. Social media. Think about your social feeds. They're not just feeds of text anymore. They're vibrant cascades of photos and, most importantly, videos. On social media, users can express themselves and build communities and inspire others. They're not just passive consumers. They're active creators. Social media thrives on visual engagement, and maintaining that quality throughout the process is crucial. And that's where Android shines. On Android, we prioritize maintaining the visual quality of content throughout the entire pipeline as it's created, shared, and consumed, ensuring that every detail, every nuance shines through in the final photo or video shared across social media platforms.
Let's talk about two areas that we are focused on to improve visual quality. We are investing in modern codec formats like AV1 and HEVC to offer incredible compression while maintaining visual fidelity. This means your users' high-quality dance videos or travel footage is going to look their absolute best when shared on their favorite social media platform. No more grainy uploads. We are also transforming visual quality in social media apps by investing in HDR. HDR is crucial for a true-to-life experience. With wider range of colors, brighter highlights, and deeper shadows, Android enables Android cameras and social media apps to capture and share these moments with the richness our eyes perceive. Imagine your social feed full of photos and videos that truly pop. The Android ecosystem is seeing a shift towards modern codec formats. Device makers are increasingly utilizing HEVC for content capture in very high quality while reducing file size. And major social media apps are using HEVC for capture and upload of user-generated content. For content delivery, we are seeing a shift towards AV1. Thanks to the growing support of AV1 in Android devices, app developers are using AV1 to deliver high-quality videos while reducing bandwidth utilization. AV1's incredible compression efficiency is enabling great video experiences even in slower connections. Google Meet now serves AV1 in low bandwidth conditions even as low as 40 kbps. YouTube serves millions of watch hours of videos in AV1 to users, and Netflix has been serving AV1 to supported devices since 2021. Meta has already witnessed remarkable improvements in video quality across Facebook, Instagram, and Messenger by incorporating AV1 into their delivery pipeline. We look forward to our continued collaboration with Meta as well as other app developers to bring great video experiences using AV1. To further support developer adoption of AV1, we've integrated David AV1 software decoder in Android. This decoder is available on Android 12 Plus devices for apps that opt in to use it. It delivers 3x the performance of our current software decoder. This makes HD AV1 playback a reality for a broad range of users, even those on some mid and low-tier devices. Moving to HDR, last year, with the launch of Android 14, we've introduced Ultra HDR for photos, designed to capture and display photos in HDR quality across modern Android phones with HDR screens. Ultra HDR has dramatically improved the photo quality in Android devices, delivering rich, lifelike colors and more balanced, natural photos while ensuring seamless backward compatibility with older devices and apps. Since launching Ultra HDR in Android 14, we've seen tremendous momentum across the Android ecosystem with over 60 devices now supporting Ultra HDR. But it doesn't stop there. In addition to the incredible support from silicon vendors and OEMs, we are seeing major apps adopt Ultra HDR. This means you can capture, edit, and share stunning Ultra HDR photos in the apps that you already use and love. This is now becoming a reality for video as well. Major social media apps like Instagram and TikTok are bringing HDR video experience to users, enabling them to capture and share videos in stunning HDR quality. Whether it's a breathtaking sunset or a heartwarming family gathering, HDR video brings your videos to life like never before.
We've been hard at work bringing together the information you need so that your apps can take advantage of the latest in hardware and software innovations. So first, we have the Camera and Media Developer Center, which is your one-stop shop for resources and guidance on all Android media and camera topics. And that's whether you're a beginner or a seasoned expert. The Developer Center is where to find the latest updates on our media and camera developer solutions, along with inspiration on how to improve media creation and consumption experiences in your app. So keep an eye out for opportunities to connect with us further and share your feedback. Next, I'd like to introduce you to Socialite. It's a new sample app we've created to demonstrate how the libraries and APIs we're working on can be used to create compelling social media experiences. So you can chat one-on-one with your favorite animal friends, send them a picture or an edited video, and scroll through the media you've shared. Socialite is built with modern best practices, so we hope it serves as a helpful example to see these features in a realistic scenario. It is still a work in progress, so we invite you to join us on our GitHub repo to help make it even better. And last, but not least, as a sort of companion to Socialite, we're announcing the new Social and Messaging Developer Center, covering best practices around messaging and communications, as well as a social focus on media creation and consumption that ties in closely with the work we've done in the Camera and Media Developer Center. So learn how to level up your social apps to leverage the latest hardware and software advances and make Android a better place for consuming and creating social media.
We've supported LE audio in Android since Android 13, paving the way for next generation of wireless audio. And our partners have been shipping chipsets, headsets, and devices with substantially improved experience. LE audio enables low power consumption, reduced lag, and richer sounds, along with newer advanced capabilities like wireless audio sharing. In most cases, you won't have to change your app to use LE audio. Some apps are using start-stop Bluetooth scope for VoIP purposes. Switching to set communication mode or the new telecom Jetpack library will ensure your apps are compatible for the next wave of devices. Users love the immersive experience spatial audio provides. Over 60 apps now deliver content to over 100 devices that support spatial audio. In Android 15, we are enabling support for dynamic spatial audio over LE audio. Besides opening dynamic spatial audio to a growing ecosystem of LE audio accessories, LE audio provides lower head tracking latency and better bandwidth utilization for an even more immersive experience. Jolanda will now cover how we are helping your apps capture the world.
When it comes to social media, capturing and sharing those special moments is key. That's why we're introducing new tools to empower even more creative content creation. We're expanding access to advanced system camera features. We're investing in the CameraX library to streamline your development. And all the while, we do this with the newest modern APIs, Jetpack Compose, Kotlin, you name it. So let's see what this means for you. With the Extensions API that is available for both Camera 2 and CameraX, you can seamlessly integrate advanced camera features into your app. So you can do things like bokeh, face retouch, HDR, and night mode. Support for these extensions has been growing rapidly. So by now, there are already over 90 different Android devices that have support for this kind of features. So let's take a closer look at one of them, the night mode extension. Did you ever try taking a picture in the dark? With the small sensors that you have in the small lenses in devices, it is actually quite hard to do low light photography on Android and on smartphones in general. With the night mode extension, we're giving the device manufacturer more control over the image capture process. So, for example, the device manufacturer can choose to capture multiple frames or apply some post-processing in order to increase the brightness and to increase the quality of the captured image. We introduced night mode in Android 13, and in Android 14, we're adding more support for things like strength control and giving you some updates on progress so that you can give the user an even better experience. Snapchat is one of the apps that recently improved their low light experience, and they shared with us that they implemented new features 50% faster using this Extensions API. They used the flexible and extensive API to build full-fledged applications on demand, without it negatively impacting performance and stability. Now, while the night mode captures still images and it focuses on increasing the brightness of those still images, we're also introducing low light boost. And low light boost is a new auto exposure mode that we're introducing, which is going to make your previews and your video capture in a better brightness. So how does it do that? Well, it can reduce the frame rate, increase sensor sensitivity, or apply some localized processing in order to increase that level of brightness. And the amount of boost automatically adjusts. So if you're in a light scene, it doesn't have to do anything. If you're in a very dark scene, it will do it more and more and more. And you actually also get feedback on how much of this is applied. So you do have to keep in mind that there's a trade-off, of course. We can't do magic, unfortunately. So you can expect a bit more motion blur and increased noise when you're in a very, very dark situation. However, low light boost is fantastic for framing shots, scanning QR codes in the dark when you can't enable your torch, or brightening social media video captures. Now, let's see how we can implement this. We start by creating an extension method on the camera manager class, and we call it isLowlightBoostAvailable. It takes a camera identifier and it returns a Boolean value, which indicates if low light boost is available for that specific camera. We start by checking the API level, because low light boost only is available on SDK level 35 and up. Then we retrieve all the available auto exposure modes, and we check if the low light boost exposure mode is in that list. If so, we return true. If not, we return false. So then when we're creating the capture request for this specific camera, if our extension method returns true, we can set the auto exposure mode to low light boost priority. And with that, you actually already got it working. Now, while the camera session is running, we can actually see if the low light boost state is active at a given point in time by listening to the capture completed callback. When this contains a capture result with the low light boost state variable set to active, we can inform the user. Like you can imagine doing something like a little moon icon in the top or something similar, where you're indicating that, at the moment we're in a dark stage and we're gonna help you to increase the brightness. Okay, now while these camera features offer incredible potential, we do need to be strategic about how we approach them. Hardware capabilities vary, and a device can limit the number of features that you can enable simultaneously. So can prevent overheating or it can prevent any issues. So it has this kind of automatic limiting of features, which is built into the device. We introduced the feature combination query API. This is a new API that lets you basically at runtime check if a certain combination of features is supported by that device at that point in time. So let's take an example. Let's think about an app that we're building, yeah? And we're recording a soccer match. We want users to be able to easily record soccer matches, something where we have a subject that is fast moving. Now, in an ideal situation, what we want to do is we want to record that video with 60 frames per second using preview stabilization in 4K and HDR, everything all at once. Now, maybe that combination is not available on a certain device. And at that point in time, as an app developer, I can choose which of these features are most important for my app. So in this case, because we're recording this fast-moving object, the frames per second are actually really important. We don't want any blurriness there. Stabilization also, we're moving around a lot. But maybe HDR and 4K are less important. So the first thing we can do is we can drop down the HDR video. And then if that combination is still not supported, we could drop down the 4K requirement. Now, if we still aren't able to do this, as a last resort, we can get rid of the stabilization and we can still focus on 60 frames per second. Now, similarly, in another example, if I was building a social media app, I might have completely different requirements. So I might want to focus on the preview stabilization and on HDR while dropping down to a lower frame rate. So how does that work in code? Well, we can create an ordered list of session configurations according to my app requirements, and then iterate through that list. And the first one that we find that will return true through the query API, we will use that one for using it in our app at that point in time. Okay, let's shift our focus to CameraX, a Jetpack library that we have designed to simplify integrating camera functionality. It offers a consistent experience across devices, and it handles many compatibility issues for us. That way, you can focus on development, and you don't have to focus on compatibility. Already, 32.8% of our top 1,000 apps that are using the camera sensors are doing so with CameraX. And we see this number steadily increasing. YouTube Short is one of the apps that recently switched to CameraX. They saw an 11% decrease in their metrics for failed short creations. And they saw a 5% decrease for inconclusive creation states. Both of these metrics are historically quite difficult to debug and to resolve. So by just switching to CameraX, they already improved this by a lot. And as an added bonus, they were able to remove over 1,000 lines of camera code. The CameraX library offers a modular approach to development. So you can choose what features make sense for your app. Do you want to use a preview in your application? Use Camera View or Camera View Finder. Do you want to include video streaming? You can use Camera Video. If you want to do something with machine learning, use MLKit Vision. And for example, if you want one of the cutting-edge features that we discussed, we have camera effects and camera extensions. Last year, we released the CameraX 1.3 stable. And we added support for concurrently streaming the front and the back cameras, HDR video capture, and configuration options for various video capture settings, such as cropping, mirroring, and frame rate. We also added a way to apply custom effects to camera streams, switch camera during a recording, and the last one, work with audio. So you can mute your streams, or you can read the current amplitude level. And now we've released CameraX 1.4 beta. It's adding a lot more features. So, I can call out a number, but I will tell you what's actually in this cool new release. First of all, Ultra HDR image capture. We had Karthic explaining it at the beginning of this talk. In CameraX, you'll be able to implement this. We also added a new artifact called Camera Effects. This artifact contains GPU-accelerated implementations of the Camera Effect API that efficiently manipulates camera output. So one example is the overlay effect, which lets you add a watermark or highlight detected objects in your stream. With the 1.4 release, you can also easily add stabilization of both the camera preview and the recorded video. And you can choose to use a different dynamic range for the preview versus the video capture. In addition, when you're taking images that take a long time to capture, such as the night mode example that we discussed before, we added APIs that allow you to receive updates while the image is being captured and processed. And finally, we're adding more Kotlin idiomatic APIs to the library that will improve the code readability of your Kotlin apps. So let's take a look at some of the implementations. I made a long list, but we want to see code, right? In version 1.3, I said that we added support for HDR video capture. So let's see how to implement this. We can first check if the device supports HDR video capture. We iterate through the available camera infos until we find one that offers a non-standard dynamic range. So SDR here stands for a standard dynamic range. We want to find one that does something else. If we find it, we save the camera selector that belongs to it and the encoding type. Then, when we're setting up the CameraX video capture use case in CameraX, we set the dynamic range encoding to be used if HDR is enabled. And with that, your application will automatically record in HDR. So that was video. Let's go to still images. As I said, we added HDR, Ultra HDR image capture. So how do you do that in code? We first checked for availability when setting up the image capture use case. And we set it as the default output format. And that's actually all we need. So we can go to the next one already. Concurrent camera. We added dual stream support, so you can preview or capture more than one camera stream at once. Most logically, the front and the back camera. So how do we do that? Well, to check if the setup is available, we iterate through all the available concurrent camera infos, and we search for one that has both the front and the camera option available. And with that, we can go and create a single camera config instance for both of those. And we can bind them to the camera provider instance. Then in our UI, we can show both of these streams in a preview. We take the surface requests that come out of our view model, and we forward them to the camera composables. You can overlay one stream on top of the other, as you see in this example, by clipping the top one using just standard compose modifiers that you see here at the bottom. Which actually brings me to the following. I am a huge fan of Jetpack Compose, and to be honest, I am genuinely excited to bring to you today that we're adding Jetpack support for camera in Jetpack Compose. Cool. This was an applause I really wanted. This is so cool. I'm really happy with this. And let me explain a little bit about what this library actually is and does. So when you add this library to your code base, it helps you with a couple of different things. It helps you to show a camera preview on every device and form factor in a consistent way. Now, this might sound very logical, but actually it's quite hard nowadays because we have foldables, we have tablets, we have laptops, we have all kinds of things that we run Android on nowadays. So we want to make sure that it works in a very robust manner and it will do the same preview without you having to worry about all these kind of weird rotation and aspect ratio issues. In addition, we're also taking care of the camera and surface life cycles. So these life cycles can sometimes interact, and it's quite difficult, which we'll see later. So we're taking care of that for you. And finally, we're enabling complex interactions in the camera coordinate system. So we make it easy to convert a XY coordinate on your screen into a XY coordinate in the camera sensor system. That way, if you want to implement something like tap to focus and you need the location on screen, it's easy to kind of do that conversion and implement that. Now, with this new Jetpack Compose artifact and with the Kotlin APIs that I mentioned, we're working towards making it easier for you to integrate camera into a modern Android architecture. Now, in our recommended architecture, we use a unidirectional data flow. So events flow from your UI down, and then state flows back up. This should ring a bell, hopefully. Now, when you're dealing with camera, this is actually quite difficult, because the camera needs to render its content directly to a UI surface, instead of a composable. And the camera has a lifecycle of its own, which is managed by the process camera provider. Now, To deal with these complexities of these interacting life cycles, we're working on opinionated guidance and samples in addition to those APIs to help you implement this in your app. Now, I think it's time to start up Android Studio, right?
Yes, let's do this.
Let's implement the camera preview. So I think we're going to start with just a camera preview composable. And I created a project, sample, quite basic project that already has quite a lot set up. So we have the permissions set up correctly, we have the camera set up correctly, all of that. The thing we're going to focus on is the UI. So I think we can start with a very naive implementation. Let's be, I don't know, starting developer. We think, what do we want to do? We want to implement a camera preview. Let's do it through an Android external service. This is an element, a composable, that is part of the Compose core library. So we're not using any fancy libraries here yet. We're just using the core Compose part. And when that service is created, the on-service Lambda is called. So what we do is we have basically asynchronously a creation of a service in the background and a callback when it's done. Now, we forward this service to our service request, which is part of CameraX. And that kind of binds that UI to our camera code. And that way, it starts rendering to the service. Now, when the service request is done with it, it calls a release method to kind of say, I'm done, it's fine. So with that, our naive approach is done. Let's run it.
Whoa. We look like we're in a fun house right now. I mean, this could be a desired effect in an app, I think.
It's a bit skewed, isn't it?
Yeah.
Yeah. Okay. No, that doesn't work. Let's close it off.
We'll go farther. Let's do split screen and let's do. Yeah. Hey, now it's gone completely.
Okay, now it completely broke.
Yeah.
Yeah. No, that doesn't look good. Okay.
Let's get rid of that.
Let me explain what happens. As I said, we were naive developers, right?
Right.
So what we saw happening is we have a camera sensor, which has a certain aspect ratio, and then we have a device screen, which has a different aspect ratio. So the moment we render naively just directly onto that surface, what's going to happen is it's going to stretch. What it should do is add bars to the bottom and the top, black bars, so that we have the right aspect ratio. And then when we went to split screen mode, what we saw was that our screen went black. This has to do with the life cycle. Like, we're not correctly, offloading those life cycles and working with them. And this is why we were saying the new viewfinder artifact works well. So let's replace our code with the new one, and let's see if that actually works any better. Viewfinder, yeah, looks good.
Why are we getting a compile?
Oh yeah, we have some boilerplate code there.
But we're getting
we have an attached to viewfinder. And we have an error because we're doing a demo, and that's how it's supposed to go,
that's
right?
Pretty much what happens. All right, we're going to do this the bad way.
Oh.
I know, don't do that. I'm just...
What could go wrong?
Yeah.
Yeah, no, you broke it.
Wow. Okay.
You actually did break it.
I did break
Magic.
it. I know what I did wrong. Hold on. I put it in the wrong place.
Yes.
There we go. That's going to work. You see?
That should be better.
Yeah, sorry about that, everyone. But we're doing it live.
I know.
All right.
True.
Hey, that looks like us. All right.
Okay.
All right.
I want a picture.
Okay.
Let's take a picture.
Let's take a picture.
Oh.
And it just crashed again. Wait, hold on.
We talked about this.
Wait.
Actually, let's take a look at the controller that we have. We have a camera controller.
We do have a camera
with
controller, and it says to do. And doesn't return anything.
Yeah, with it to do, it's not going to work. This one was on purpose. Trust me. So we have a CameraX 1.3, we said, but we also have a CameraX 1.4. And in the CameraX 1.3 library, what we did is we basically don't have that much Kotlin support yet. And so we added much more in the 1.4 release. So let's start with the implementation that would be in Android, in the Compose or in the library 1.3. So this is, again, what you would be implementing in 1.3. And as you can see, we're going to need a lot of lines of code in order to just take a picture. And the reason behind that is that we're using this kind of wrapping around a callback-based API in order to go to a Kotlin-friendly coroutine API. So all of that lines of code are actually just boilerplate to kind of go from callback-based land into coroutine-based land. So in the 1.4 library, we've added APIs to make this a lot easier. So we've added suspend methods, for example, for the take picture method, That should make this a breeze. So let's take a look at what this would look like in the 1.4 release. That is a single line of code, isn't it?
Yeah, that is. All right. All right.
I think with that one, we're ready for like a final actual picture.
Okay, hold on. We're doing this for social media, though.
Yeah.
So I think we need to jazz this picture up. All right. I'm just going to assume this is actually going to work.
Okay, can we do it with the audience, you think?
Okay. Oh, yes, absolutely.
Okay,
All right,
okay.
everyone, this is your chance to be on social media. Yes. All right.
Great work, guys. Amazing. Thank you so much. Okay, let's go back to our slide deck, I think we're ready to go. I think we can go look at our resources, our learning resources, because as you saw, it's not trivial to implement a camera app, but we're making it much, much easier. So what can you do to learn how to do this as well? Well, we talked about Socialite before, and in Socialite, we're using the latest Compose and Kotlin APIs to allow you to send images or videos to your furry friend of choice. Now, we're also aiming to add more complex camera use cases in here soon, so stay tuned for more. And next to the Camera and Media Dev Center and the Social Messaging Dev Center that Dan already mentioned before, all information about our stable camera features can be found on the Android developers' camera page. And finally, many features that we discussed today can be found in the Jetpack camera app, which is a great reference app on how to implement CameraX features using architecture best practices, Kotlin, and Jetpack Compose. And with that, I'll give the word to Caren, who will continue our journey and talk about content consumption and editing with Media 3.
All right.
All right. Thanks, Jolanda, for showing us how to build apps that capture those special moments in life. But I personally think that most things in life are better when shared, including the photos and videos that you capture on your phone. So now we're going to take a look at what we've been working on to help give users the best media experiences on Android. The Jetpack Media 3 library group is our recommended way for your app to playback, browse, and edit media. The 1.0 version was first introduced last year, and we're now seeing that it's being used in over 30% of the top 1,000 apps in the Play Store. We've been making lots of additions and improvements to Media 3 since its release, and so we're going to spend some time today going over those changes. Let's start by taking a look at Exoplayer. Exoplayer helps you support media playback in your app, and we recently made it part of the Jetpack Media 3 library, with some recent highlights, including low latency live streaming, image playback, so you can support a mixed playlist of both videos and images, improved playback integration for server-side ad insertion, better testing support, and numerous other performance improvements and API simplifications. To help make it easier to create a holistic playback experience, we've also combined Exoplayer with a revamped media session library. So let's take a closer look at what this actually means. When a user starts listening to a podcast on their phone, they probably expect to be able to pause and restart through the media controls on their lock screen. So in this case, it's important for you to publish a media session to advertise the playback and then receive playback commands from external sources. The media session library enables you to easily create a session for your Exoplayer playback. And an important benefit of using media session is being able to provide media resumption. So going back to our previous example, that user listening to a podcast, they should also be able to easily resume listening, even if the app has been closed or if the device has been restarted. So let's take a look at how media session has made supporting playback much easier with just a few lines of code. So the first thing your app is going to need to do is declare the media button receiver to enable playback resumption. And next, you need to implement the on-playback resumption callback. This is called when the user triggers an action to resume playback. So for example, if they press the play button on the system UI or from their Bluetooth headset. In this callback, your app should then handle restoring the playlist with the correct start position so the user can transition seamlessly back to their streaming experience. Supporting this type of proper playback resumption has been made much easier with recent API improvements. So this is a great time to test whether your app actually supports playback resumption well and implement changes if needed. All right, so we talked a little bit about playback. Now let's switch gears a bit and talk about Media 3's Transformer library. Transformer covers media editing use cases, such as converting media files between formats or downscaling. For example, a great use case for Transformer is transcoding from HDR to SDR. Transformer can also be used to transform the media structure, such as combining multiple media items together or trimming portions of a video. And lastly, you can also use Transformer for audio and video processing use cases, such as cropping video frames or applying custom effects to media items. I could talk a lot more about these APIs, but I think it's going to be a lot more exciting if we do a live coding demo. So we're going to try to build a simple media editing app, and if we can go to Andre's studio here. So what we're going to work with here is the social app that Dan introduced earlier. One of the use cases in the app is recording and then sending videos to your other users. We're going to make things a bit more exciting by sprucing up the videos that we record, and then we're going to accomplish this using Transformer. All right, so the first thing we want to do is set up a Transformer instance. We're going to be using this to both apply effects to our video and also export the final result. Okay, we got that set up, ready to go. Next, we will create a media item from the video that we want to apply edits to. All right, now we can start adding effects to our video by creating an edited media item with a list of audio effects we want to apply and a list of video effects. And I'm currently in the black and white era, so we're going to start by using a grayscale filter. All right. Now everything is ready to go, so we can use our Transformer instance to start exporting our edited video by giving it a save file path. Great. Okay, and lastly, I think we'll need to add a listener to our Transformer so we know when the export is complete and we can have Social Light play back our edited video. All right, fingers crossed, we're going to run the app. And I think we can use some audience participation here, Dan. What do you think?
Yeah, let's okay, we're going to send a message to the sheep
All
here.
right.
Okay, so here we go. This is your chance. Do the wave. Fantastic. All right. This is your chance. Do the wave.
Nice. Yeah, that was pretty cool. But we're going to take it a step further, and now we're going to try adding a text overlay to our video. So in order to do this, the first thing we need to do is create an overlay effect. And since we're going to be adding a text overlay, we're going to be using spannable strings, so we could set the appearance of the text, such as its size and its color. All right, now that we have that ready, let's go ahead and use this to add another effect to our video to apply some text overlay. All right, fingers crossed again. We're going to run the app.
All right, let's do this.
If you didn't get in the first video, this is your chance to get in the second video.
All right, let's send it to the parrot this time. All right. Here we go. Here's your second chance. Live from I/O. All right.
Yeah. All right, so that was all pretty cool. But besides just applying effects to videos, Transformer can also transform media structure, such as stitching together multiple media items. So I think it'd be cool if maybe we added like a photo at the end of our video. The first thing we're going to need to do is we're going to create a media item based on the photo we want to add. All right, nice. And now that we have that, we can create an edited media item sequence based on the video we have from before and this new photo we want to add, and then build a composition from it. So there was a very similar code, but now we are going to add a photo to the end of our video, hopefully. So fingers crossed again, we're going to run the app. All right, another chance for you to get into our I/O video.
All right, this time I think you should be in the video too. There we go. All the way around.
And now it's going to end with a nice I/O logo.
All right.
All right, well, that was pretty cool how we were able to build a demo app like that in just a few minutes using Transformer APIs. But what's even more impressive is how apps have been using Transformer and Media 3 in production and the results they've been seeing. So if we could go back to the slides. For example, YouTube Shorts recently migrated from using an in-house solution to using Transformer for importing media into their app. After the migration, they saw reduced video processing time, particularly on high-tier devices. Utilizing Transformer APIs also made their app more robust, reducing transcoding failures and timeouts by 19%. YouTube Create is another team that has seen success from adopting Media 3. YouTube Create is a new video creation app designed to help mobile creators edit and enhance their videos. And using Transformer as a transcoding library, the app was able to reduce player seek latency by 33% for a smoother playback experience. The team also used Exoplayer for decoding use cases and found that it made feature development both convenient and fast by allowing the team to offload the technical complexities associated with codec interactions. Similarly, Meta migrated to using Media 3's Exoplayer's extractor APIs for the video creation process and saw a 60% decrease in native crash rates. Google Photos is another app that has been using Transformer APIs in production and saw similarly impressive results. The Photos app allows users to perform edits on their videos. After adopting Transformer for parts of the editing flow, videos that were rotated or trimmed in length were both saved much faster. Rotated videos had a median save latency by 79%, while trimmed videos had a median save latency reduced by 63%. The Video Diary app, 1 second every day, also recently migrated to using Transformer and saw multiple improvements in their app. Using Transformer, video encoding performance was up to 5 times faster. On a Pixel 7 Pro, a video encoding operation measured 38 minutes using the in-app library and just 7 minutes using Transformer APIs. Because of this improved speed, they were now also possible to support 4K and HDR videos. Next, yay! Next, due to the simplicity of Transformer APIs, they were also able to reduce the lines of relevant code by 30%, making their code base more readable and easier to maintain. Using Transformer will also mean that the app no longer have to ship the in-app binary for all platforms, which is estimated to save them 57 megabytes in their app bundle. And lastly, since making the switch, the app has observed better performance and less crashes, particularly on lower-end devices. So we're excited about how all these apps are using Media 3 and Transformer APIs and seeing both improved performance and reliability. There's a lot more we want to do, including improving the experience from browsing short-form content, adding new media editing APIs, and adding new previewing capabilities to enhance the media editing experience. So keep a lookout for new updates coming to our Media 3 library by keeping an eye out for our official Media 3 GitHub repo. And now, back to Karthic.
Thanks, Caren. I got it. We are working hard so your apps can unlock the full potential of modern devices, from stunning HDR to advanced editing tools, enabling you to inspire and engage the next wave of social media creators. To help you with this, we are making it easier than ever to leverage all this power using libraries like Media 3 and CameraX. Samples like Socialite and updated documentation in our Developer Center give you the resources to bring your ideas to life. We can't bring these great experiences to Android without your help. So thank you for joining us today, and we look forward to seeing what you'll build next.